All right, now is your time for mathematics. So mathematics is basically when you don't know what you're doing, but you do this cool process and you get the right answer. So what I'm going to do is I'm going to do this special awesome process. I'm just going to simply take my coefficients of my dividend. I'm going to write them down. Are you satisfied that I wrote them down correctly? Now this number over here is to represent my divisor. And since my divisor was x minus 2, for some reason this changed to positive 2. All right, fair enough. Now, time for mathematics. Did I get my right answer? That's what I'm after. Is my answer correct? Well, let's see. I'm actually going to do this terrible long division process in about 10 seconds. I'm going to add down, multiply across. Add down, multiply across. Add down, multiply across. Let's begin. I'm going to start there. I'm going to add down. There's 1 plus nothing is 1. 1 times 2, right? Multiply across is 2. Negative 2 plus 2, right? Add down is 0. Multiply across is 0 times 2 is 0. Yikes, almost made a mistake. Negative 1 plus 0 is negative 1. Negative 1 times 2 is negative 2. 7 plus negative 2 is 5. 5 times 2 is 10. Negative 4 plus 10 is positive 6. Wouldn't it be nice if this last number represented the remainder? Wow, that's amazing. Wouldn't it be nice if this next number represented the constant? What are the chances? Wouldn't it be nice if this number, negative 1, represented the coefficient in front of the x? Wouldn't it be nice if this 0, wow, x squared. Wouldn't it be nice if the coefficient, the first coefficient in our quotient was 1? And it is. So somehow this process, which is called synthetic division, very quick, but it can let you synthetically or divide and perform division operations. All right. Let's go into synthetic division. I'm going to leave this setup for synthetic division till a little bit later. Like I said, I do believe that we learn best when we do this, when it's an algorithm. Generally, it's always best just to do it and then try to come up. It's my opinion anyways. What I'm going to do is I am going to note my divisor. So this is synthetic division. If my divisor is x minus a, the number that went in front was a. So this is x minus 2. That implied that a is 2, so 2 goes on the left side of that division mark. Simply, I note the coefficients now of each term. I have to please note that my polynomial is in descending order of degree. And this one, it is. The coefficient in front of x to the power 4 is actually a hidden 1. X to the power 3 is negative 2. X squared is negative 1. In front of the x to the power of 1, it is 7. And this is x to the power 0, or the constant, and that's minus 4. And now what we're going to do, we've already done this, we're going to simply add down. 1, multiply across. 1 times 2 is 2. Add down. Multiply across. Add down. multiply across, add down, multiply across. So now there is my answer in here. So now I need to interpret what it means. Always in synthetic division, always, this first and the immediate number on your right is your remainder, which can be represented by r or x to the power of -1. And then we simply count up our degrees. This is x to the power of 0, which is our constant term. This is x to the power of 1. This is my next number here is going to be x squared. And this is going to be x, the coefficient of x cubed. So it's 1x cubed. The answer to this is 1x cubed. By the way, that should be an x cubed. Plus 0x squared. Now we don't have to write 0x squared, but I'm going to minus 1x plus 5 with a remainder of 6. Or x to the power of 3 minus x plus 5 with a remainder of 6. That does seem like magic. I agree. So, set up for synthetic division. So here, I'm going to put add down, multiply across. And hopefully that's enough. We should practice enough to do it. And if you don't find my explanation good enough, you should maybe write stuff down in the margins so that you can understand this at a later time. So both the divisor and dividend must be in descending order. Of degree. Exactly what we have here. Include 0 coefficients. That is very important. If our coefficient is 0, we have to include our coefficient still, because 0 is a placeholder. The next thing I'm going to do is we're going to simply write down the coefficients. Now, where are we going to write down those coefficients? Right there, coefficients of dividend. That's where so we don't even worry about the variables, we just worry about the coefficients. And last but not least is if divisor is x minus a. So the divisor is in the form x minus a. All we note here is that we have a divisor of a. So since it was x minus 2, all we wrote was 2. Now, generally people say, oh, isn't it just the opposite of what it appears? Okay, I'll concede that if this is -2, I don't know what opposite means. It will appear as the negative, right? The negative of -2 is +2. But really, what's happening, what is a if it's in x minus a form? Well, a here is 2 because it's x minus 2. Right. Please set up this, and we'll carry it out. Press pause. Let's see if you do it right. All right. So if I'm trying to write this division, I'm going to take the short step, and a lot of people think this is wasted work, but I'm just going to simply write out my divisor and my dividend in descending order of degree and indicating 0 coefficients. This is not essential, but wow, does it result in much better work, okay? Then I can see my dividend here. X to the power 3, my coefficient will be 1. My coefficient of x squared is 0. My coefficient of x is 1. And my coefficient of x to the power of 0 is -7, or my constant. Now, if this is in the form of x minus a, x plus 1 is in the form of x minus a, what goes here? Well, that would have to be -1. And the setup is complete. What's going to happen? Magic. I'm going to add down. So 1 plus nothing is 1. 1 times -1 is -1. Add down. Multiply across. -1 times -1 is +1. Add down. Multiply across. Add down. Wow, that is pretty spectacular. And I'm done. All I have to do is interpret the meaning of this. This last always represents my remainder, or x to the power of -1. This represents my constant, x to the power of 0. This is x to the power of 1, and this is x to the power of 2. And it should make sense, because x plus 1 times what will give me this? Well, it's going to have to be x to the power of 2, right? Something of degree 1 multiplied by degree 2 is going to be degree 3. So here, this is 1x squared minus x plus 2 with a remainder of -9. And that's all we have. Okay? Give me a second. I want to take you on a little detour, and we're going to talk about basic numbers. All right. You know 3 goes into 17, right? I'm just going to take us back. The divisor is 3, the dividend is 17. What is the quotient? Let me find out. 3 goes into 17 5 times. 5 times 3 is 15. I subtract it, but I'm terrible at subtracting, so I'm going to add the negative, and I end up with 2. So I have a remainder of 2. In other words, I can say, wow, ... Maybe this is not terribly exciting to you, but let's carry on. What obvious information can I tell you guys? I don't know. That 3 goes into 17, or 17 divided by 3 is 5 with a remainder of 2. We can also represent that as 17 divided by 3 is equal to 5. And if we chose to write it, now please don't write it in decimal form. I'm going to write this as a fraction. So 17 divided by 5 is equal to 2/3. Now what happens here? If we were to take a look, and you know this, you may not have applied it or considered this in a long time, but my dividend is here, right? So there's my polynomial, there's my big nasty polynomial. So 17 divided by my divisor is 3. And my quotient, now I'm running out of colors. Yikes, I'm going to switch to blue. My remainder is here, 2. Right? And look what's happening here. So 17 divided by my divisor is equal to my quotient plus, right? We can put a plus sign there and it's the same. My remainder over my quotient. Or we can even take 5 2/3. Like if I take 5 2/3 very quickly and I multiply it by 3, we know that should be equal to 17, right? Probably, let's take it back to a simpler example. 4 goes into 12 how many times? Well, 3. But then 3 times 4 is also equal to 12. All right, let's press pause. That was a nice detour. Let's see where we're going. All right, I promise that we are in the home stretch here. So the result of a division of a polynomial in x. So for instance, what is that polynomial? I don't know, let that polynomial be represented by p of x. So there's our polynomial. And if it's divided by a binomial in the form of x minus a. So our division, what is our division then? What were we trying to say? Well, if we take a polynomial p of x and we divide it by x minus a, we could represent this as q of x plus r over x minus a, where q of x is the divisor plus, and r is our remainder, and x minus a is our divisor. So this is really saying, if I'm doing 7 goes in, or 3 goes into 17, well, that's 5 with a remainder of 2. So in other words, 17, that'd be my dividend, divided by 3 is equal to my quotient, which is 5, plus 2 over 3, my remainder over my divisor. Remember, we're just dividing after all, except for everything gets a lot crazier in terms of division in polynomial. It just looks nastier. Let's do an example. Now, I certainly wish that I would do an example that I've already done. So we're going to express x to the power 4 minus 2x cubed minus x squared plus 7x minus 4 divided by x minus 2. And we're going to write it in the form of qx plus r x minus a. The quotient, remainder, and my divisor. So, for instance, it would be certainly nice to know would have been great if I would have done this division right here, right? And in fact, if you look to the work above, we have. We know that this was equal to x to the power 3 plus 0x squared minus x plus 5 with a remainder of 6. We knew that. So if we're going to express it in the form this, q of x over r, q of x plus r over x minus a, well, this division is equal to x to the power of 3 plus 0x squared minus x plus 5 plus. Instead of saying a remainder, we can just say 6 over x minus 2. That's all it's asking. It's almost like asking you for this form.